In this video, we'll talk about F-ratio interpretation, ANOVA notation, but first we're going to start off talking about our statistical hypotheses for an ANOVA. So for the null hypothesis, the concept isn't any different than we've talked about with our t-test hypotheses, in that the level or the value of the factor does not affect the dependent variable, so that there's no difference between the groups. So in the population, this is equivalent to saying that the group means do not differ from each other. And we would write that like this. So our null hypothesis says that the group means are equivalent to each other. They don't differ from each other. Now, the alternative hypothesis is a little bit more complex. It basically states that there's at least one mean difference among the populations, but it could be a variety. It could be the mean of population 1 is different from population 2. Population 1 could be different from population 3, or population 2 could be different than population 3. And there's so many ways to say that. What the acceptable notation is that just it's not the alternative hypothesis. And you wouldn't want to put that the mean of population 1 doesn't equal the mean of population 2 and it doesn't equal the mean of population 3, because then you'd have to get all of those would have to be different in order to get your significance. So we saw the F ratio in the last video, and we said that this is variation within the treatments that's expected regardless of any treatment effect plus the treatment effect over the differences with no treatment effect, so within our groups. So if the null hypothesis is true, the size of the treatment effect is near 0. So if the size of the treatment effect is near 0, the ratio is going to be close to 1. Because when you take away the treatment effect, you're left with the same thing in the numerator and the denominator. If H1 is true, the size of the treatment effect is much more than 0, which means that your F value is noticeably larger than 1. So just looking at our ANOVA notation and formulas, so we already talked about K being the number of treatment conditions or the number of levels in a factor. N is the number of scores in each treatment. So if we only have 3 treatment groups, then we'd have N1, 2, and 3, but we go on for the number of treatments we have. A big N is the total number of scores in the entire study, or it could be the number of treatment levels times small n. T is the sum of scores for each treatment. So it's kind of like a sum of X for each treatment group. And G is the grand total of all scores in the study. So it's the sum of T. And there's really no universally accepted notation for ANOVAs, so other sources may use other symbols, but just for to be consistent with what our text uses, this is the notation that we'll be using in this class. All right, so if we're looking here at the sample table, let's see if we can figure out what our values are. So what is K? K is the number of treatment conditions or number of levels in a factor. So we have 1, 2, 3 treatment conditions. So K equals 3. Now how about our N? So the small n is the number of scores in each treatment. So we have here 1, 2, 3, 4, 5 different scores in each treatment. So n equals 5 for each sample. Or you could put n1 equals 5, n2 equals 5, and n3 equals 5. So next is big N. So big N is the total number of scores. So here, because each sample has the same amount, we could go K times N, which is 5 times 3, which is 15. Or we could add up 5 plus 5 plus 5, which is also 15. G is the grand total of all scores in the study. But first we need to get what our T is. So T is the sum of all these scores. So 4 plus 3 plus 6 plus 3 plus 4 is 20. 0 plus 1 plus 3 plus 1 plus 0 is 5. 1 plus 2 plus 2 plus 0 plus 0 is also 5. So to get g, we add up the sum of t, right? So the sum of t is going to be t1 plus t2 plus t3, which is 20 plus 5 plus 5, which equals 30. So now we know that G is 30. So K is the number of treatment conditions, N is the total number of scores in each treatment, big N is the total number of scores in the entire study, and G is the grand total of all scores, or the sum of T. And these are our individual t-scores that we just did. So some other calculations that we'll need to calculate the mean. So the mean is going to be, so the mean is equal to t over n. We'll also need to know how to get our sum of x squared. So we need to get our we need to square each of these values. And then we get the sum of x squared here. Which is 11. Which is 9. So I squared each of my x values, added them up to get that sum of x squared. And when we add those all up together, we get 186. We'll learn how to calculate the sum of squared deviations in our next video.